Number 13. Now, this problem, one way you can do this is you can rearrange. You can make it look like y equals mx plus b. You would subtract 4x from both sides, divide by -3. We've been doing that a lot, and we've been practicing that a lot. So feel free to do it that way. But I want to remind you that there's also another way to do it, and both methods are equally correct, so feel free to rearrange this. Okay, and I'll show you what it looks like rearranged so that you can choose to do it that way. But remember that the other way to do it is by finding the two intercepts, right? Remember we can find the y-intercept, and the way that we find the y-intercept is we plug in 0 for x. And hopefully you remember this. This is an important concept. 4 times 0 is 0, so that's -3y equals -12. I divide by -3, and I get y equals 4. So that gives me 1 point, right? That says, well, when the x-coordinate is 0, the y-coordinate is 4. And then I find the x-intercept basically by doing the opposite, which is instead of plugging 0 in for x, I plug in 0 for y. And so this is just 3 times 0 is 0, so I end up with 4x equals -12. And when I divide by 4, I get x equals -3, which gives me this other point, right? When x-coordinate is -3, it's because I plugged in 0 for y. And then I can plot these 2 points. 0, 4, 1, 2, 3, 4. And I can plot this point as well. -3, so I'm going to go left 3. And those 2 points give me the line. Okay, so remember this strategy? You can use this strategy. If you want to rearrange this equation, that's also fine. What you should end up with if you rearrange this equation is y equals, let me make sure I do this, 4/3 x plus 4. So if you want to rearrange instead, right, you should end up with this. And notice it gets you the same graph, right? You'd go up 4, and then rise over run, you'd actually, you'd have to run 3 and rise 4. You'd actually run out of space to do it, right? But you could just, you could make up for that by going, instead of going to the right and up, you could actually go down and left, right? You can always just do the opposite. And so notice it actually would get you even the same 2 points. Okay, so you're going to pause the video now, and over here, you can rearrange if you want. If you're more comfortable with that, it's fine. But I would encourage you to just try this so that you're at least comfortable with both methods, because being comfortable with both methods is important. Okay, so pause now. Go ahead and try this problem on the right. Ask for help if you need to, and then move on. Number 14. I have a nice, clean slope-intercept form, y equals mx plus b, but this is not an equal sign. Okay, it's an inequality. So it starts off the same, which is I say, oh, here's the y-intercept. So I'm going to go to the y-intercept. 1, 2, 3, 4, 5. -5 on the y-axis. And then my rise over run is 1/3. So I'm going to rise 1 and run 3. Rise 1 and run 3. But now is the point where I stop and I say, okay, I have an inequality, not an equation. So what does this symbol mean? Well, this symbol means less than. And remember that if it doesn't have that line underneath, if it's not less than or equal to, I use a dotted line. Okay, so first I'm going to draw this as a dotted line. And then I need to decide, which direction do I shade here? Which direction should I shade? Should I shade this bottom part here or this top part up here? And the way that I can decide, there's a little bit of a shortcut here, but shortcuts are easy to forget. So the real way to decide is to plug in a point and say, okay, well, is this a solution? And the easiest point to plug in is this one, 0, 0. So if I plug in 0, right, this is 0 is the x-coordinate and the y-coordinate here. So if I plug in 0 for both of those coordinates, let's see what I get. 1/3 times 0 is 0. So I get 0 is less than -5. Now we need to decide if that is true. Well, let's think about it. Let's think about a number line, right? And I'm just going to use this graph as a number line. Right, so here is 0. Here's 0 on my number line, right? And negative 5 is down 5. 1, 2, 3, 4, 5. So which number is less? Which number is lower? 0 or negative 5? Well, negative 5 is lower. Well, let's see what this says. This says 0 is less than negative 5, right? Remember, here's the L. You make an L with your left hand. That's the less than sign. This says 0 is less than negative 5. Is that true? Is 0 lower than negative 5? No. 0 is more than negative 5, right? 0 is more than any negative number. So this is actually not true. That's false. That statement is false. And so what that means, and I'm going to just erase this so you have space for your next problem. What that means is that this point right here, 0, 0, is actually not a solution to this inequality. And so when I shade and I choose which side to shade, I don't want to shade this point. I want to shade the other side. So when I shade, I'm going to shade over here. And this is my answer. Okay, so pause now. Try this one. Ask for help. Inequalities are tough, so ask. Next problem. This problem was the problem that the most people got wrong on the whole test. This is the problem we struggle with the most. Okay, so we'll take a careful look at it, and then you'll have a chance to practice it as well. Okay. So first, I'm going to graph it. And when I go to graph it, for a moment, I'm just going to pretend this is an equal sign, right? And I'm not going to worry about the inequality sign yet until I get to actually graphing the line. So first, I'm going to find my y-intercept by plugging in 0 for x. I'm going to divide by negative 5 here. So remember, I plugged in 0 for x, so the x coordinate is 0, and then I got that the y is negative 2. And then I'm going to find my x-intercept, and I'm going to do it by plugging in 0 for y. So I get 2x equals 10, and I divide by 2 on both sides. I get x equals 5, so that means the x-coordinate is 5. When the y-coordinate, look, I plugged in 0 for y, is 0. So when I plot these 2 points, 0, negative 2 is here. 5, 0 is here. Now, whoops, I went to draw my line, but I actually missed a step, which is I need to look at this symbol. This is a greater than symbol. Remember, if there's no line underneath, it's a dotted line. Okay, so this line is dotted. If it was like this would be solid. Okay, but it's not. So this is a dotted line. I'm going to draw it dotted. Now I need to decide which way to shade. So I'm going to plug in 0, 0. And remember, that means I plug in 0 for x and 0 for y. Because what I'm doing is I'm saying, well, hey, does this point work? That point 0, 0, does it work? Is it a solution? 2 times 0 is 0. Negative 5 times 0 is 0. So this becomes 0 is greater than 10. Is that true? Is 0 greater than 10? Is 0 a larger number than 10? No. Right? You'd way rather have $10 than $0. So this point is not a solution. And so if it was a solution, like if it said 0 is less than 10, well, yeah, that's definitely true. And I would say, okay, well, I'm going to shade this side of the graph. But it turned out it was not true. And so I don't want to shade this side of the graph. I want to shade the other side. Okay. Now you're going to try this problem. Pause, ask for help, get the help you need to do this correctly.